In the previous video, you learned about the basic formula of probability, which is the priori probability small n over capital N, and as well as you learned about the different operations involving events that would be needed in the formulas that will be discussed in this video. Now in this video, we shall focus on the second and third formulas, which are the formulas for the union of two events and formulas for the probability of the complement. The second formula for probability is the additive rule. So let capital A and B be two events. Then the probability of the union of events A and B is equal to the probability of event A plus the probability of event B minus the probability of the intersection of events A and B. Now, in the case that A and B are mutually exclusive, then the probability of the intersection of A and B is equivalent to the probability of the empty set, which is also 0. Now, if this is 0, then that means the formula of the additive rule will now be reduced to the probability of A union B is probability of A plus the probability of B. So let us have an illustration. The probability that a student passes algebra is 2/3, and the probability that he passes English is 4/9. If the probability of passing at least one subject is 4/5, what is the probability that he will pass both subjects? In order for us to efficiently use the additive rule, let us let variables to represent the events in this situation. Now, the event that the student would pass algebra may be represented by the event A. Now, the event that the student passes English would be the event capital B. Now, the event of passing at least one subject would mean that the student passed algebra or passed English or passed both. So this means that passing at least one subject can be represented by A union B. Now, the event that the student will pass both subjects would be the event A intersection B. So according from our additive rule, the probability that A union B is equal to the probability of A plus the probability of B minus the probability of A intersection B. Now from the given problem, the probability of A union B is actually given as 4/5. Now the probability of A or passing algebra is said to be 2/3. So P of A is 2/3 plus the probability of B, which is passing English, is actually 4/9. So we have plus 4/9 minus x because we're looking for the probability of A intersection B. Now to solve for this x value, we can transpose that negative x to the left side and transpose 4/5 to the right side. So this gives us x is equal to 2/3 plus 4/9 minus 4/5. And you can verify that the answer here is 14/45. Let us have another example. What is the probability of getting a total of 7 or 11 when a pair of dice is tossed? In this problem, the experiment is rolling a pair of dice and we're looking for the probability of getting a total of 7 or a total of 11. Now, the word or indicates that we're looking for the probability of the union of two events. So let us let A be the event that the outcome on the pair of dice will have a total of 7, and event B would be the event wherein the outcome will have a total of 11. Now observe that A and B are mutually exclusive because it's impossible to roll a pair of dice and get two different sums. So which means the probability of the intersection is 0. Now since we're looking for the probability of the union, the probability of A union B is simply probability of A plus probability of B. Now the probability of getting a total of 7 is 6/36 because there are 6 outcomes that will give us a total of 7. And these are 1, 6, 2, 5, 3, 4, 4, 3, 5, 2, and 6, 1. So these are the outcomes on the pair of dice that will give us a total of 7. Now, for the event B, for total of 11, there would only be two outcomes wherein the total could be 11. And these are 5, 6 and 6, 5. So therefore, the probability that the pair of dice will have a total of 11 is 2 over 36. Now, adding these two fractions will give us 8 over 36 as the probability of getting a total of 7 or a total of 11. The third formula in probability is the complementary rule. It states that the probability of an event A plus the probability of its complement is equal to 1. Let us illustrate the complementary rule. The probability that it will rain today is 0.65. What is the probability that it will not rain today? Let us let A be the event that represents it will rain today, while the event it will not rain today is represented by A to the C, or A complement. We know from complementary rule that P of A plus P of A complement is equal to 1. So in this case, we have 0.65 plus X is equal to 1. And in this case, the probability that it will not rain today is 1 minus 0.65, which is 0.35. For a second example, what is the probability that a letter after B will be selected in the English alphabet? So there are 26 letters in the English alphabet. So instead of counting all the letters after B, we shall just use the solution 1 minus 2 over 26. The frequency 2 here refers to the letters A and B, which are actually not part of the event that the letter should be after B. So this difference, which is 1 minus 2 over 26, is 24 over 26. And this is the probability that a letter would be after the letter B. Let us illustrate the additive and complementary rules using a contingency table. A random sample of 200 adults are classified below according to the criterion gender and criterion level of education attained. So if an adult is selected at random, what is the probability that the adult selected is a female and has reached up to secondary level only? The first item is intersection. So it's the intersection of females and those adults who has reached up to secondary level only. Now from the contingency table, we just need to get the intersection of females and secondary level, which is actually 50 out of 200. Now for the second item, we're looking for the probability that the adult selected is a male or has reached up to elementary level only. So this means in symbols, we have P of M union E because of the keyword or. Now using the additive rule, this is equal to P of M plus P of E minus the probability of M intersection E. Now the probability of M is 88 over 200 because there are 88 males out of the 200 adults, plus the probability of E is 83 over 200 because there are 83 adults who have reached up to elementary level only, minus the probability of M intersection E, which is equal to 38 over 200 because there are 38 males who have reached up to elementary level only out of the 200 adults. Now, simplifying this will give us 133 over 200. And then the last one is that we're looking for the probability that the adult selected did not reach college level. So this means that we're looking for the probability of the complement. Okay, so this is 1 minus the probability of those adults who have reached college level. So this is 1 minus 39 over 200, which is 161 over 200. So now you have learned the second and the third formulas of probability, which are the additive and the complementary rules. In the next video, you shall learn the last three formulas for probability.